Okay, so today I'm going to be teaching you how to do permutations and combinations. So first of all, what is a permutation? So permutations are, as it says right here, number of ways that an item can be arranged or ordered in a particular order. Okay, and permutation, order matters. The way that items are arranged matters a lot, and because of that, there's going to be more permutation than combinations. If you put, 7p5. It's going to be it's going to give you a number that's a lot greater than 7c5. I'll show you in a couple examples later. But permutations, a good way to know is that they're typically much larger. So here's an example. How can we arrange A, B, and C? So first we already have A, B, and C. So I'm going to put I'll write it again. A, B, C, A, C, B. Then we have B, C, A, B, A, C, C, A, B, and C, B, A. Okay, so over here it should be 6, 1, 2, 3, 4, 5, 6. There are 6 different ways that we can arrange arrange those letters in that order. Okay, so now how many ways can we? Here's another example. How many ways can we stack 3 scoops of ice cream flavored vanilla, strawberry, and chocolate? So because it's the same amount of digits, I'm just going to tell you it's going to be 6 as well. But we'll just go over it just to so to better understand. And this is technically not permutations, this is technically factorials, but they tie in with the concept. So let's do this. So vanilla, strawberry, and chocolate. Now we have vanilla, chocolate, and strawberry. Then we have strawberry, vanilla, and chocolate, strawberry, chocolate, vanilla. Then chocolate, vanilla, strawberry, chocolate, chocolate, strawberry, vanilla. Okay, so this is the equation for permutations. As you see, this is NPR and then equals n factorial over n minus r. So this means how many ways can we put or arrange r out of n? And n will always be the larger number. That's like the set of whatever you're doing, and then r is the only specific, the small like sample, I guess, of that group that you're trying to test out. So here we have a little example word problem. How many groups of 5 people can we form from 8 people? Okay, and so what we're going to do is we're going to do the same thing here. So we know that 5 is r. I'll just write it here. R equals 5, and p equals, n equals 8. Okay, so we're just going to put that there. So we got 8, p, 5. Okay, so that's how it's written. Okay, and so now we're going to do it just like it says on the equation. Okay, so we got n factorial, so we have 8 factorial over 8 minus 5, and then we're just going to move that. We're going to make an arrow, and that's going to be 3 over 8 times 7, because remember this is factorials. 8 times 7 times 6 times 5 times 4 and then times 3. We're just going to leave that like that. So we're just going to multiply all those numbers together, okay? And I'm just going to do it right here. Okay, and that gets us 1,344, and we're going to divide that by 3. And that equals, I hope you can see that on the camera, but that should be 408. That is the amount of ways we can form groups of 5 people from the original 8 people, okay? How many ways we can arrange them in that order. And as you can see, it's quite a large number. If this was a combination, it would be a much smaller number than that. Okay, so this is combinations. So combinations, we select numbers or items from a large set without regard of their order in which they were selected for. So to summarize, basically, order does not matter, and because of that, there's going to be less digits for it, because in permutations, it does matter, and so there's more, and so because of that, combination is always going to be less than permutations. As I said in the beginning, if it's something like 8p3, that's going to be a large number than 8c3, okay? So here's the formula for it. It's a little bit different, as we can see, it's NCR equals n factorial over n minus r, same as the other one, but that's going to be a factorial times r factorial. Okay, so let's get into it. All right, so here are some examples. Out of 6, choose 2 winners. So this is an easy combination example, so this is going to be 6C2. So what we do now is, first of all, I'm just going to write the equation somewhere so people can see. So n over n minus r, close parentheses, factorial, and then r factorial. Okay, so I'm just going to write this how I can. Okay, I basically translated all of that into this, so I'm going to do it even more. So 6 times 5 times 4, and oh, before that I got to do this. 4. I'm just going to cross the 4 here, and I'm going to cross the 4 here, because that's how you do it. And so that 6 times 5, that's going to be 30, and divided by 2, that would actually be 2 times 1, but since anything times 1 is itself, that's going to be 15, okay? So that's going to be the amount of combinations that you can have out of those 6 when you choose 2 winners. And obviously it's much smaller than if it would be a permutation. So now we're going to do the next one. Out of 10, choose 3. Okay, so we have 10. Then we have 10 here, minus 3. Okay. I'm just going to move this down a little so people can see. 9, 7. And because there's it's the same number, we don't really have to do that. Okay, that's just the rule. So 10 times 9, that's 90. Then we have 3 times, that's going to be actually 3 times 2 times 1. And that's going to be 6. So now we got 90 divided by 6. I think that's going to be a decimal. That's, oh, never mind. It's going to be 15 also. Okay, so now we have the third example. Out of 7, choose 5. Okay, so we got 7. And we got 5 that we're going to choose. So we're going to have 7 minus 5. Okay, that's going to equal, what, 2 factorial and 5, like that. I'm just going to make this line here so it's not annoying. 7 times 6 times 5. And as I did with the other ones, it's the same one. We're just going to cross it out, okay? I apologize for the mess here, but so now 7 times 6, so that's, what is that, 42, I think? 42 divided by 2. It should be 21, I believe. And you can try these with the calculator, which I'll show you in a moment, and it should give you the same thing. So now let's go to the word problem. This one's probably a lot more complicated. So a student group consists of 8 women and 5 men. How many different committees or groups can we choose with 4 women and 2 men? So that's really confusing. You probably have to go over that a couple times. But what we want to do is, it's asking us that how many groups can we do with 4 women and 2 men. So what we're going to do is, out of those 8 women, we're going to choose only 4 of them, okay? And then out of those 5 men, we're going to choose 2 of them, okay? 2 lines so people can see. All right, and basically what we do, it's very simple. We just multiply those 2. And in fact, I'm going to show you the calculator rule now, just because I don't really want to do this whole thing, and it's much easier. I don't know how your teacher will do it, but in the real world, we usually just use a calculator. So I hope you can see the calculator. So how do we do this? So we're going to put 8 here, and then on your TI-84, you got to go to math, and then you're going to go all the way to the far right. And then since this is a combination, we're going to go to 3, or press enter when you go to the 3. The permutation is right here in number 2, but we're doing 3, so we're going to press 3. 8, and then 4. And so that's going to be 70, okay? And now we're going to do the men. So we're just going to, I'm going to clear this. I'm going to type 5, go to math, all the way to the far right, and then go to 3, the NCR, then put in 2, and it should be 10. So that's going to be 10. And so now what we're going to do is just multiply those 2, and it should be 700. So there's 700 ways that we can form groups with four women and 2 men, okay? You have to really think about it. You have to take it slowly, because I understand that some people might get confused. But there are others that are much more confusing. This one was very simple, okay? Just multiply the 2. Okay, so now what's the difference between combinations and permutations? So I went over this a couple times. Again, the combinations, it doesn't matter their order. In permutations, their order does matter. Because of that, there's going to be a lot more combinations. So here's an example. We have red, blue, and yellow. I don't know what this is. Maybe it could be t-shirts or cars or something. It doesn't matter. So we have 3 different things, okay? And we're going to choose 2 from those. So since we're going to do both of those, I'm going to write 3. We'll do combination first. 3C2. And I'm over here. I'm going to write 3P2, okay? So I'm just actually going to write this whole thing down literally so that we can see the difference between it. And so you can better understand it visually. Okay, so out of those 3, we're going to choose 2. So we want a group that we can choose with 2. So we're going to write red, blue, red, yellow. And write blue, red, blue, yellow, yellow, red, and yellow, blue, okay? So we're also going to put that on the calculator. I mean, you could do that easily, but I'd rather just do it in the calculator since it's much faster. Okay, so we're going to do the combinations first, and that will give us 3, okay? The permutations, that should give us 6, okay? And so over here we have a difference, you see? As you can see, the combination has 3 and the permutation has 6, and the permutation has a number that's much greater than the combination. So because of that, I'm just going to highlight the different combinations that we can have. So we have red and blue, we have yellow and blue, and then there should be another one in between. I think it should be red and yellow. Okay, red and yellow. Okay, so those are all the different combinations, and you can see these other ones are just like those, except that they're just flipped. Their order matters, and because of that, there's more of them. So as you can see, all the boxes are the combinations, and all the rest are the permutations. Okay, so that's basically how to see it visually. So thank you for watching.